So let's look at the following examples. I started off, actually, I probably should have started off with number 2 because it's easier. Actually, let's do number 2 first. Yeah, we can do that.
Let's do it then.
All right, so consider the following dice game. A player gets no points for rolling a 1, 2, or 3, 5 points for rolling a 4 or a 5, and 50 points for rolling a 6. We're going to find the expected value and the standard deviation for that. And everyone's like, yeah, we did this, but so let's start by making a probability chart. Okay? So we'll have X, oops, and the probability that we're getting X. So I'm going to lump 1, 2, or 3 all together.
Is that the big X or the small X?
Take your pick. It's the small x.
Oh, okay.
So what's the probability of getting a 1, 2, or a 3?
1.5.
Yeah. And a 4 or a 5?
1/3.
1/3. And the probability of rolling a 6? 1/6. So we could do that, but we're not really interested in the value of the roll, are we?
No.
We're really interested in what?
The points.
The number of points you can get. So let's do it this way. And I did that on purpose because people always, want to start that way. And I'm like, well, that may not be the best way to start, really. So I'm going to get 5 points for 1, 2, or 3.
Then you get 0 points, right?
Pardon?
Then you get 0 points.
Oh, sorry, 0 points. My fault. Thank you. That's why I keep Savannah around. And the probability for that is 1/2, right? And we get 5 points for rolling a 4 or a 5. And the probability of that we already figured out is 1/3. So it doesn't hurt to do this first. And we get 50 points for rolling a 6. And the probability of that is 1/6. So our mean, remember, is the same thing as our expected value. So that's going to be 0 times 1/2 plus 5 times 1/3 plus 50 times 1/6. Anyone want to take a wild, don't put anything in. I want you to take a wild guess. It is a whole number.
20.
1. 5.
It's 10.
Oh, man.
Well, it can't be 1. 5 over 3 is more than 1. I want to change my guess to 10. All right, and so then we need to figure out our standard deviation. So our standard deviation is going to be
Wait, I need to figure that out. How to do that.
the square root of the difference between our x value and our expected x, and it doesn't matter which order you're going to do them in because you're going to square it, multiplied by the probability of getting that.
Can you say it again? Sorry.
Yeah, it's the difference between the expected value and the value for whatever x you're using.
Mm-hmm. Oh, and then you do plus.
And then you do plus, and you do it for the next
5
one.
minus 10 squared times 1/3.
Yes.
Oh, okay.
And then 50 minus 10, quantity squared. times 1/6. If we didn't put that under the square root, what would we be finding?
Oh, the variance.
We'd be finding the variance, which is not the same word as variability. You have to be really careful about that. I'm bad about it. I've been doing this for a couple of years now. I'm still bad about it. So this comes out to be 18.028. Now, what if the points awarded were doubled? So I get 0 points, 10 points, and 100 points.
It'd be the same.
Well, let's actually do it. You can do this without doing any of this, but let's go ahead and do it.
Wait, would the mean just be double?
Well, we'll see.
Oh.
At this point, so I'm going to have 0 points, 10 points, and 100 points. Probability of getting 0 points is a half, 10 points is a third, and 100 points is 1/6. So the mean is going to be 0 times a half plus 10 times a third plus 100 times 1/6. Now, without calculating anything, look back at the original calculation and tell me, what is this going to come out to be?
20.
It's going to come out to be 20. We've doubled these values, right?
Oh, but the other one, yeah.
All right, now, the standard deviation. It's
Did
going
these
to,
problems ever ask us to find the variance?
they might. Is going to be 0 minus 20 squared times 1/2 plus 10 minus 20 squared times 1/3 plus 100 minus 20 squared times 1/6. Now let's compare this calculation to the original calculation. So this was 10, right? We squared it, that's 100. This is going to be 20, squared is going to be 400, right? This is 4 times more. Even after we multiply by the 1/2, it's still going to be 4 times more whatever this is, right? When we do this, that's going to be 5 squared is 25. This is 10 squared at 100. It's 4 times more, but when we take the square root, it's 2 times more. So this should just be 2 times the 18.028. So it's 36.056. So if we have doubled the points, we have now doubled the standard deviation and doubled the expected value.
So when would they stay the same? Because I remember the standard deviation at some point stays the same.
We'll see if we can get to that one. So now, imagine playing the game twice. What are the mean and standard deviation of your total points? Well, I'm not going to go through making a chart for this. I'm going to use the rule. The mean is going to be the expected value of x1 plus x2. This is a rule that you need to memorize. It's the expected value of x1 plus the expected value of x2. So we're back to the original game, by the way. I don't know that I made that clear. I guess I should have said the original game twice. So that's going to be 10 plus 10 is 20. And that makes sense. If our expected value or our average playing it once is 10, the average playing it twice should be 20. Where people get messed up is on the standard deviation. So the standard deviation squared, that is the variance, is going to be 18.028 squared plus 18.028 squared. When you do it twice, it's like you're doing Pythagorean theorem. A squared plus B squared gives you C squared. If you did it 3 times, you would square them all, and you do square them 3. It'd be 18.028 squared 3 times, et cetera, et cetera, et cetera. So it turns out that the variance is 650. So the standard deviation is the square root of 650, which is 25.50. It's not exactly 0.5, that's why I have the 50.
So for the mean, when you would add, why wouldn't you multiply? Because they're both
Wait a minute. When you add what, multiply what? You never specified.
Oh, so like for like the x1 and x2, why wouldn't you multiply? Because they're independent events. It's like 2 separate games.
I'm not finding a probability.
Oh. Okay.
I'm just finding the expected value.
So what were you saying about the variance? You said that the standard deviation squared is the variance.
Correct.
So basically you're finding the variance and square rooting it?
Correct.
The variance of the 2 games, though.
Right.
Okay.
And you have to do the variance so that you're doing Pythagorean theorem. Right? Where you're going to take that standard deviation squared plus the standard deviation squared gives me the standard deviation of the whole thing squared. Suppose you and a friend play a game. What are the mean and the standard deviation of the difference in your points? That is, what's the mean or the expected value of x1 minus x2? Well, that's going to be the expected value of x1 minus the expected value of x2. The mean expected is going to be 10 minus 10 is 0, which makes sense. We expect you to have an average of 10. We expect me to have an average of 10. The average expected difference is 0. The standard deviation, whether we're adding or whether we're subtracting, it's the same calculation. So it's 18.028 squared plus 18.028 squared. So the standard deviation is the square root of 650 again, which is approximately 25.50.
Why is it the same?
It doesn't matter whether you are adding or subtracting the points. The standard deviation behaves the same way, and it's because you're squaring, if you want to think about it that way.
Oh, okay.
That kind of helps me.
Yeah.
There's a much longer explanation that I can follow, but can't come up with on my own very often. But you're going to have more variation. If you subtracted them, you would say that the standard deviation was 0. That doesn't make any sense.
Yeah.
So whether you add or whether you subtract, you're increasing how variable your data set is. Because when you subtract, or if you add, when you add, the mean was 20, right?
So the likelihood of getting numbers that are further away are
Well, and you could, if you add, the least you could get would be 0, and the most you could get would be 40, right?
Mhm.
If you subtract, the most you could get would be 20. The least you could get would be negative 20. Your spread of your
Data.
your data is exactly the same.
It's just like moved. Okay.
Exactly.
Positive or negative.
Exactly.
And then for 2A, how did you know that we were multiplying, or like we were trying to find the mean and standard deviation for the points itself and not the rolls?
It doesn't say, but I don't know why it would be asking for the expected value of the roll.
Oh, okay.
I mean, you could find the expected value of the roll, but that doesn't tell you anything about the game.
Yeah.
Okay? All right, let's go back to number 1. So consider this game. So if you're playing this game, first thing, you give the person $5. That gives you the opportunity to play the game. If you draw an ace of hearts, this is out of a standard deck of cards, you get $100. Okay? If you draw any other ace, you get $10. And if you draw any other heart, you get $5. The question is, would you be willing to play this game? Well, the answer is probably not. But let's see why by calculating the mean winnings and the standard deviation. Okay, so on this one, you have to be a little bit careful. So if you have paid $5 and you win $100, what is your net winnings? $95. Okay, so when we're looking at our X's here, we want to look at not how much money are they handing me, although you could do it that way and then go through and subtract the $5 at the end. It's easier to go, okay, what is my net winnings? So if you draw the ace of hearts, your net winnings are $95. What is the probability of getting that?
1 out of 52.
1 out of 52. If you draw any other ace, you get $10. So what's my net winnings? $5. What's the probability of having a net winning of $5?
3 out of 52.
3 out of 52. If I draw any other heart, they give me $5. What are my net winnings?
0.
0. And that's what people don't think about on this. They're like, I won $5. How much did you pay to play the game? $5. You're an idiot. So what's that probability? 12 out of 52. There are 12 hearts that are not aces. And this is the other part that gets people in trouble, is right here at the end. They're like, oh, those are all the possibilities.
-5.
Oh, what if you get 0?
Yeah, what if you get anything else? There's a lot of anything else, isn't there?
There is.
There's the 13 hearts, which win you money, plus the 3 other aces that win you money. So that's 16 that win you money. And Miss used her calculator to subtract that.
Sorry. I can't do mental math like that.
Is it 36?
Yeah.
There's 36 out of 52 chance that you're going to lose money.
Pretty bad game.
What a game.
Well, let's talk about that in just a second. Okay? So my mean is the expected value for X is going to be 95 times 1 out of 52 plus 5 times 32 out of, or 3 out of 52 plus 0 times 12 out of 52. No, you don't have to write that, but I always do for completeness. Minus 5 times 36 out of 52. This comes out to be negative 1.35. You lose money more often than you gain money on this.
Oh,
So that's the average amount of money you make.
Right. The average amount of money that you make is negative 1.35.
Right.
Okay? And then the standard deviation is going to be the square root of, you have to be careful about this, it's 95 minus negative 1.35 squared. The mistake people make is they do 95 minus 1.35.
So it's really 95 plus 1.35?
Yeah. Times 1 out of 52 plus 5 minus negative 1.35 squared times 3 out of 52 plus 0 minus negative 1.35 squared times 12 out of 52 plus negative 5 minus negative 1.35. I am totally out of room. Squared times 36 out of 52. And double check me on this, but I got 13.802.
You want us to check?
Please do. Make sure that I put in those numbers correctly.
This might take a while.
So what y'all do for breakfast, Mr. Davis?
Not a whole lot.
Every Thanksgiving.
I did log wrestling,
Log wrestling, what is that?
What?
Sounds very interesting.
where you have a really big tree that has fallen and you've cut up logs into lengths about
yeah.
like this, and you try to wrestle them up onto a platform for them to dry out.
Oh. Wow. What do you do with all that wood?
Firewood.
Oh. It's a lot of firewood, Mr. Davis. You could have had a bonfire with that.
I have a lot of firewood. Oh, I've got things set up for a bonfire too.
Oh.
I've got so much wood down at my
Oh, I messed
house.
up. I forgot to square all of them.
You should be able to go back and
Just give me a
fix
second.
that.
Oh.
Just give me a second. I got this.
It's okay, May. You can be on calculator duty next time.
Oh no, my past record proved that.
Oh yeah, right. Never mind. We'll keep it. We'll keep it.
I'm doing good. Just give me a second. There we
I
go.
know you are. You're doing so great. You're the best at everything.
Okay.
I like the ducks.
Thanks. My wife gave me those.
Really?
Yeah.
Yeah, Savannah loves those things.
What?
She has them all in her Jeep.
Ducks?
I do.
You see it? Did you see him up there? Oh, who's that?
Oh yeah.
Actually, I had my own little Christmas miracle this morning. The
13.802. Yes.
excellent. The lights at the top of the tree didn't come on when I plugged it in this morning, but after it was in for a while, they came on. Now, ignore the fact that there's a bunch of lights out at the bottom.
Up, yep. I don't
I
know.
don't see it.
I didn't see it in the desk.
I like the calculator.
Calculator ornament.
Did someone give you that?
Yes. It was one of the secretaries here years
Does
ago.
it work?
That was a good question.
I'm trying to remember if that one is a solar powered one. If it is, it may still work.
You should conduct entertainment.
All right. So here's the question. Notice on this one, you're not losing a whole lot, but you're losing over $1 each time. What if we changed this to if you had any other card, they gave you $1. So they're always giving you money. You would certainly feel better about it, wouldn't you? But your expected value, how different would that be? Well, if that were the case, this would be 4,
Yeah.
right? So let's see. 5 times 36 out of 52 minus 4 times 36 out of 52. It would change your expected value by about 0.7. So you'd only be losing on average about 60 cents per.
Per game?
And that's how casinos work. The games you play in a casino, not talking about poker where you're playing against other people, but any game of chance like roulette or something like that, the way it's set up is so that you're losing a little bit every time. You don't notice it, but you're losing a little bit. If I was to play this game, what I would do is anytime, if I take negative 1.35 and multiply it times how many times I have played, if at any point I have lost less money than that, I would quit. So let's say I've played it 10 times and I've only lost $10. I'm ahead of the game
Yeah.
because I should have lost $13.50. Or the other way to do it would be play it often enough, and you may never get there, but play it often enough to where I'm actually in positive territory. And as soon as you're in positive territory, quit, because you're way ahead then.
I don't know if I want to risk you going that far in debt to casino.
Well, and that's actually part of, so what happens with people is they win some at some game of chance, and so they're like, oh, and as soon as they've won, they're hooked,
Yeah.
and they keep playing. What you actually should do if you're doing any kind of gambling like that is at any point where you have more money than you started with, stop. Or the other way to do it is go, okay, I'm going to go play this game of chance, and I'm willing to lose up to, and you pick a dollar amount. And once you have lost that dollar amount, stop playing. And what some people say is they're like, it's entertaining. It's just like going to a movie or going to the theater or whatever. They count it as entertainment, and they're willing to pay for the entertainment, which is a smart way to think about it. The dumb way to think about it is, I'm going to win all this money, and you just keep playing, and you just keep getting in deeper and deeper and deeper.
Yeah.
When we were in Louisiana, my dad worked all over the state, and he would talk about games of what they called bourrée. It's a Cajun game. And he said, people are betting their houses, their boats, their all this stuff on this game. After a while, and he goes, that's just crazy.
That's so stupid.
Anyway, this is why mathematicians don't play the lottery.
So I know it's such a small
'Cause you
chance,
know
but
the
there's still a
odds behind
chance
it.
though.
Yeah, there's a chance. But there's also a chance I'm just standing in line to pay taxes.